So this short lesson is going to examine scientific notation, and it's going to build from a few of the concepts from the video from last week about exponents. So just quickly a review of why we use scientific notation. It just makes it easier to write really large and really small numbers. So for instance, if you had a number like 6 billion, it's much easier to write 6 times 10 to the 9th than it is to write all those zeros. So just to review how we get scientific notation, it's a number between 1 and 10 that can include 1 but can't include 10. So 1 counts but 10 does not, somewhere in between that, including 1, times 10 to some power. So here, this number, the decimal point would be right here in 6 billion, and what we would want to do is move it back as many times as we need to land on a number between 1 and 10. So 1, 2, 3, 4, 5, 6, 7, this would put me at 600, 8 puts me at 60, and then 9 spots puts me at 6.0. So I'm finally in between 1 and 10 by moving 9 spots. So now to represent this large number, 6 billion, we want to use a positive exponent to go back to the start to represent this really large number. So 6 times 10 to the 9th is just this, it's scientific notation, it's just an easier way to write 6 billion out. So that's why we use it. So now let's do a couple of examples of multiplying numbers in scientific notation. So I'm just going to continue with this 6 times 10 to the 9th. And, well, actually on second thought, I will return to this and I'll start off with something slightly easier. So I'm going to start off with 2 times 10 to the 9th and multiply that by 3 times 10 to the 4th. So what we want to do here is multiply the exponents, in other words, the 10 to the 9th power and 10 to the 4th power. And we also want to multiply the digits. So 2 times 3 is 6. And 10 to the 9th times 10 to the 4th, and this is a little review of the previous week's video, comes out to 10 to the 13th power, because we would have a total of 13 tens that we'd be multiplying. So the answer for 2 times 10 to the 9th multiplied by 3 times 10 to the 4th is 6 times 10 to the 13th. Okay? So let's look at 2 more examples. Four times 10 to the 11th times 2 times 10 to the negative 3rd. Again, we want to do the digits and get 8. And we'll multiply the exponents, which remember means adding, or excuse me, multiply 10 to the 11th times 10 to the negative 3, which means adding the exponents. So 11 plus a negative 3 is 10 to the 8th. So our answer is 8 times 10 to the 8th. Now, there's one other situation we want to be careful about. I'm going to illustrate that right here. Suppose we have something like this, and this is where I'm going to return to 6 times 10 to the 9th multiplied by 2 times 10 to the 5th. Same procedure. Let's do the digits. You can get 12. Multiply that by 10 to the 9th times 10 to the 5th, which is 10 to the 14th. Okay? But you should hopefully be recognizing that there's a problem with this right now in that it's not in scientific notation because this number right here is not between 1 and 10. That's the rules that have been agreed on. So what we need to do is we need to take this 12 and put it in scientific notation and then multiply it by 10 to the 14th. So what I'm going to do is I'm going to take my decimal point and move it until I land between 1 and 10. So if I start at 12 and I move it once, is 1.2 between 1 and 10? Absolutely. So it becomes 1.2 times 10 to the 1st because we only moved it one spot, and we use a positive 1 because we want to go back and represent that bigger number in 12. We want to represent it by moving it back to the right. So now I have this, and now I'm going to multiply by 10 to the 14th. So this comes out to 1.2 times 10 to the 15th when I add those two exponents. So that is the final answer. So we just have to be careful that when you multiply the digits, if you land outside of 1 and 10, in other words, if you're not equal to 1 and below 10 in that range, then you need to make an adjustment by moving the decimal point either to the right or the left depending on the situation. Okay? All right, so that concludes this short lesson.